All right, let's talk about one of the most important decisions you'll ever make when you're designing a system. Picking your database. Seriously, this one choice can be the difference between an app that can scale to millions of users and one that just completely falls apart. So let's get into it. So let me ask you, what's that one single choice that can set your app up for incredible success or doom it to fail under pressure? Yep, it's the database. Getting this wrong is like trying to build a skyscraper on a foundation of sand. It might look okay at first, but when the real load comes, it's just not going to hold. When you get right down to it, there are two fundamentally different ways of thinking about this. On one side, you've got the world of relational databases. You've probably heard of them as SQL. And on the other side, you have non-relational databases, or NoSQL. Each one has its own philosophy, its own strengths, and picking the right one is all about what you're trying to build. Let's start with the classic, the original gangster that's been the bedrock of applications for, over 40 years now? I'm talking about SQL, the world of structure and order. The best way to think about a SQL database is to imagine a perfectly organized library. Every single piece of information has a very specific, predefined spot. It's designed for data that's predictable, highly organized, a world where the relationships between your data points are just as critical as the data itself. So, what does that mean in practice? Well, a relational database stores all its data in tables. Just picture a spreadsheet with rows and columns. But, and this is the important part, before you can put anything in it, you have to define a very strict structure. We call this a schema. And that schema is basically the rule book that keeps all of your data perfectly consistent and organized. And here's what that looks like in action. See this? We've got a users table and an orders table. Notice that user ID column in the orders table? That's not just some random number. It's what we call a foreign key, and it links every single order directly back to a specific user. This enforces a super important rule. You literally cannot have an order without a user. That's the power of the relational model. So, what is SQL's greatest strength? What's its superpower? It comes down to one simple acronym: ACID. ACID compliance is a set of guarantees that makes sure transactions, think a bank transfer or placing an order on an e-commerce site, are incredibly, incredibly reliable. ACID stands for atomicity, consistency, isolation, and durability. Now that sounds technical, but it's pretty simple. Atomicity means the whole transaction happens or none of it does. Consistency means your data always has to follow the rules you've set. Isolation means if two transactions happen at once, they don't mess each other up. And durability? Well, that just means once the transaction is done, it's saved forever. This is exactly why SQL is the undisputed king for things like financial systems. Okay, so that's the world of structure and rules. Now, let's completely flip the script and jump to the other side of the spectrum. Welcome to the world of NoSQL, where flexibility is everything. So if SQL is that rigid library catalog, think of NoSQL as a big collection of flexible file folders. Each folder, or document as we often call it, can hold whatever it needs: notes, lists, pictures, other bits of info, all stuffed into one place without a strict, predefined structure. This whole approach is built for one thing: speed, massive scale, and handling data that changes all the time. NoSQL databases don't really do rigid tables. Instead, they store data in all kinds of other formats. You'll see things like simple key-value pairs, or those flexible documents, or even wide column stores. And here's a crucial difference: they generally don't support join operations. Why? Because all the data you might need for a query is usually already bundled together in a single record. For example, check this out. Instead of two separate tables for users and orders, all of the user's information is right here in one single document. You've got their profile, a whole list of their orders, and their recent activity all nested together. This design is just optimized for pure speed. You can grab everything you need about a user in one single lightning-fast operation. And NoSQL has its other superpower too. It's called horizontal scaling, or scaling out. So instead of buying one bigger, more expensive, more powerful server, you just add more cheap, regular servers to your cluster. This makes it insanely effective for handling just unbelievable amounts of data, the kind of stuff you see in big data applications or massive real-time systems. So we have these two powerful but fundamentally different philosophies. And this brings us right to the heart of the matter for any system architect: the great trade-off. Because here's the secret of the database world: you can't have it all. When you choose one, you are actively giving up the benefits of the other. The very first trade-off is all about structure. With SQL, you get a rigid, predictable schema. You know exactly what your data looks like, and the database enforces it. With NoSQL, you get a dynamic schema. It's incredibly flexible and lets you change your application on the fly without these massive, complex migrations. So it's structure versus adaptability. Okay, the next trade-off is about how you grow. SQL typically scales up, which is called vertical scaling. You just make your one server more and more powerful, more CPU, more RAM. It's simple, but eventually you're going to hit a wall. NoSQL, on the other hand, scales out or scales horizontally. You just keep adding more cheap servers to the pool. It's almost infinitely scalable, but, well, managing a whole fleet of servers brings its own challenges. And this might be the most important trade-off of all. SQL prioritizes strong consistency. Thanks to that ACID stuff we talked about, the data you read is guaranteed to be the most recent, up-to-date version, period. NoSQL, however, often prioritizes high availability. The system will pretty much always be up and give you an answer, even if it means some of the data might be a tiny bit out of sync for a moment. You're trading perfect, up to the millisecond accuracy for constant uptime. So it all comes down to this. With SQL, you're choosing that rigid structure, vertical scaling, and rock-solid consistency. With NoSQL, you're choosing a dynamic structure, horizontal scaling, and high availability. You have to decide which of those bundles is more critical for what you're trying to build. So with these trade-offs staring you in the face, how do you actually make the right call? How do you pick the right tool for your specific project? The most important thing to get into your head is that there is no better database. The question is never, is SQL better than NoSQL? That's the wrong question. The only question that matters is, which one is the right tool for the job? You wouldn't say a hammer is better than a screwdriver, right? They're just built for totally different tasks. So here's a super simple framework to help you decide. Just ask yourself these 3 questions. Number 1, how structured is my data? Is it predictable, like financial transactions, or is it all over the place, like social media posts? Number 2, what's my primary scaling need? Am I expecting a manageable amount of traffic, or am I planning to go to the moon with millions of users? And finally, number 3, how critical is data consistency? Is it okay for data to be a little stale sometimes, or does every single transaction have to be perfectly accurate every single time? But, in reality, the choice often isn't just one or the other. Most big, modern, large-scale systems are what we call polyglot, which is just a fancy way of saying they use multiple kinds of databases for different jobs. For instance, a company might use a SQL database for their critical billing system, but use a NoSQL database to manage user sessions or for real-time analytics. They get the best of both worlds. And that leaves us with the fundamental question that you have to answer for your next project. Which foundation are you going to build on? Are you going to choose the structured, guaranteed reliability of SQL, or are you going to go for the flexible, massive scale of NoSQL? The choice, and all of its consequences, is yours.